A 3 by 3 table starts with every entry equal to 0 and is modified using the following steps. Adding 1 to all three numbers in a row, adding 2 to all three numbers in a column. After step 1 has been used a total of A times and step 2 has been used a total of B times, the table appears as shown. What is the value of A plus B? Well, here we go. Let's do it. We can make this without too much trial and error, with absolutely zero trial and error, in fact. And I'll show you. Start off exactly what they say, which is the table with all zeros. And the key to this question, in my opinion, is to concentrate on the lowest values first. So once you concentrate on the lowest values, and then you kind of incrementally go up from there. You got it? So I'll explain, of course. So here we go. So what is the lowest value? It's this 1 right here. So I have to make that a 1. So that's what I'm going to do. And let me draw in an arrow to kind of show that which way I'm going. And then the next one. Okay, so we're basically just building. So let me just make sure I put what move I did. That was an A for the first one. Okay, next one. The next smallest number is 2, so I've got to put at least a 1 there, so let's do that. Again, this was an A move. And let's just keep doing that. Again, the next smallest number is a 3. I've got to put at least a 1 there, so there we go. So you see the strategy? We're just building the numbers incrementally. Okay, next one. What's the next smallest number here? I've got a 1, 3, 2. I got to build them up. So this one I won't touch because that can't increase, but I really need to increase that one. So 1, 1, 1, 1, 1, 1. So add another 1 to that row. That was an A. So now I've got that 1. That 1 and that 2 are created, but I got to concentrate on that one. So I'm going to add 1 to that row to make it 2, 2, 2. That's 2, 2, 2. And then I've got to add another 1 to that row to make it a 3. So it'll be 1, 1, 1, 3, 3, 3, 2, 2, 2. Okay. So now I've completed that column. That column is great now. So I can't really add 1s anymore because if I keep doing this, it'll mess up that column that I just created, that 1, 3, 2. So now I've got to concentrate on this one, adding 2s. Okay, so let's concentrate on what's the next number that's in chronological order, the 5, right? So that means I'm going to add 2 to that column. So that would mean 3, 5, and 4. And the rest, of course, stays the same for now. And that is a B. So that's very important. Now we're into B's. Okay, next one. I think I can add another 2 to that column to make it 5, 7, and 6. That becomes 1, 3, 2. And that stays 1, 3, 2. Now these are complete. They're exactly like this. So now I guess I just have to concentrate on that one. And don't forget that was a B. So add 2 to that column, so that would become 3, 5, and 4. 1, 3, 2, and 5, 7, 6 remain the same. And that was a B. And then I think I need to add another 2 to make that 5, 7, and 6. And one more time, add another 2. And I think I should be complete. 7, 9, and 8. And there you go. So as you can see, if you just use a very systematic method of just building up the numbers in chronological fashion, you'll be able to get it. So how many A's did I use and how many B's? A's, 1, 2, 3, 4, 5, 6. 6 A's and B's. 1, 2, 3, 4, 5. 5 B's. So A plus B, therefore, would be 6 plus 5. And 6 plus 5 is 11. So the answer to this is 11. Pablo has 27 1 by 1 by 1 solid that he assembles in a larger 3 by 3 by 3 cube. If 10 of the smaller cubes are red, 9 are blue, and 8 are yellow, what is the smallest possible surface area of the larger cube that is red? Let's draw that 3 by 3 as best I can. Okay, so once I draw that cube, we'll get an idea. So we got 3 by 3. All right, so here we go. So that's pretty good. Okay, so when they're talking about surface area, we have to concentrate on looking at this cube, and there's 3 types. There's the one that is in the center. Let me draw sort of it over here. I don't want to mess up the diagram. And then there's one that you call edge one. So we'll call this the center one. Then there's the ones that I'll call edge. That's where 2 of the faces are visible. And then, of course, you have the corner one. The corner ones, you'll have 3 faces visible. Like that's sort of what a corner looks like. And then what's interesting is that all the cubes, there's 27, right? But if you count, there's only 26 that you can see because there's one in the very center of the cube. So I'll call that, what should I call it? Inner center? Yeah. So let's count how many there are. Corners would be 1, 2, 3, 4, 5, 6, 7, 8. Edges would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hold on. Yeah, 8 corners. Yeah, that's correct. And then centers would be, how many centers would there be? 1 on each face, right? So there'd be 6 and then 1 inner. And this whole thing should total 27, and it does. Okay, great. So I have accounted for all 27. So now we have to figure out the smallest. Okay, so the smallest possible surface area of the cube that is red. So we want to put the reds in such a way that we count as less of their faces as possible. Okay, well, obviously, one of them should be the inner one. Because if you put one of them inside, you count 0 of that cube's faces as the surface area. So I will say 1 will be inner. So let me just make a list here. So 1 will definitely, of the, how many are there in total? 10. So there's 10 in total, so 1 definitely will go in the middle. Now, the next one that has the least is the center ones. These ones. Now I can put it on the diagram, this guy right here. Because that will only contribute 1 face to the surface area. So as many as I can. So let's choose 6 of those guys. Yeah, because those are the least. And then now how many do I have left? I have 10 total, and I've used so far 7, so 3 more. Okay, so 3 more. Obviously, I'm going to choose the edge ones. And let me just see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's 12, right? Okay, so that's my distribution. So then now I've got to figure out what is the surface area. Okay, so from this one, that contributed 0. So 0. These ones, each of those would contribute 1 because it's a 1 by 1 square. Let's just put in 1 by 1 just to understand. And each of these would contribute 2 faces. So 3 times 2 times 1 by 1. Right? So this is 0 plus 6 plus 6, and that is 12. So with a little bit of analysis, you're able to get the correct answer, which is 12. A lock code is made up of 4 digits that satisfy the following rules. At least one digit is a 4, but neither the second digit nor the fourth digit is a 4. Exactly one digit is 2, but the first digit is not a 2. Exactly one digit is 7. The code includes a 1, or the code includes a 6, or the code includes 2 4s. How many codes are possible? These 4 rules I will summarize, but in a way that we can use to systematically create these codes. I don't think you're going to use like choose notation. I think it just has to manually sort of crunch out the codes. It's a little time consuming, but that's okay. The first one is the 7. Because the 7 can be placed anywhere. So that's the foundation of my code building. The next one is the 2, because the 2 can be placed anywhere except position 1. So I do have a little bit of a restriction, but just a minimal restriction. The next, of course, is the 4, because the 4 can only be placed in the first position and the third position. So that's the two restrictions, right? It can't be placed in the second or fourth. And then of course you have the last, which can be either a 1, a 6, or another 4. And the 1 and 6, it looks like that can be placed anywhere, but the 4 has that restriction. So that's how we're going to build these numbers. So here we go. Let's start. So we got 4 digits. The 7, I'm going to start by placing it in the first position, and then later we'll do it in the second position, third position, and so on. First, let's exhaust all the possibilities when the 7 is in the first position. Okay, so I've done this guy, the 7. Now the next number I'm going to choose is 2. I'm just going to put it there, and then we'll exhaust other positions. The next one is a 4. 4 can only go in the first or third, so therefore this is the only place for a 4. Now I'm down to the 1, 6, and 4. Well, I'll put a 1. There you go. I just made one number. Use the same pattern. I can put a 6. But can I put a 4? And the answer is no. No. Because the 4 cannot go in the fourth position. I just put that there just to kind of let you know that you will be restricted after a while. So far, it looks like these are the only 2. With the 7 in the first position and the 2 in the second position. So let's just keep going. I think we still can crunch out some more if I put the 2 in that position. So now the next one is 4, but guess what? The 4 I can't put because I can't put the 4 in the second or fourth. So this one turns out to be a dud. No problem. Let's put the 2 here. The 4 can therefore go there, and that could be a 1. Correct? And are there any other numbers I can create? Oh, because this number is also a dud. Because the 4 cannot go in the second position. See what happens? So we got to be careful that we make sure we follow all the rules. So let's try that again. Let's put the 2 there. Now we can put the 4 here because the 4 can definitely go in the third position. And then we put a 1. And then I think I can do the same thing with the 6. And I think that finally exhausts the possibilities when 7 is in the first position. So that produced 4. And then we just continue like this. Now we'll try 7 in the second position. So here we go. And the same thing. So the next number, of course, we put as a 2. Now, I can't put it in the first position, remember? So I will only put it here for now. And then the next number is a 4. Can I put it here? Yes, I can. And then I can put the 1, or I can put a 6. Now, I can't put the 4 at the last because 4 cannot go in fourth position. Okay, let's go back again. 7 here. Now I'll put the 2 here. And then now I'll fill in the other numbers. The 4 can go here. And then the 1 can go there. And in the same way, I can put the 6 there. And guess what? I can put the 4 there also, because that is the third position. So we got quite a few here. And then let's do this again with the 2. This time I put the 4 here. And then we kind of put the 1 and the 6 here. 6, yeah. So I got quite a few there. 1, 2, 3, 4, 5, 6, 7. So 7, when the 7 was put in the second position. Okay. And then you guys are getting the hang of this, so let's just keep going. Now, what's the next one? The 7 has to go this time in the third position. Okay. The next number I want to talk about is 2. Put it there. The 4 is the next number. I can definitely put it there, and the 1 will then go there. I think I can do the same thing and put a 6 there, but then that's it. I can't put a 4 in the last position. Okay, so let's start over. That 7 goes there, and now the 2 I'll put this position. The 4 goes here, and then I could put a 1 there. 7, 2, 4, 6 will also work. And that exhausts the scenario when the 7 is in the third spot. Now the last scenario is when the 7 is in the last spot. So here we go. The next number is going to be a 2. Next number is 4, and then I can put the 1. The same kind of thing is going to be possible with the 6, I believe. And the same possible thing is with a 4 in the third position, because that is allowed. Okay, so I've exhausted my scenario with the 2 in the second position. No, I think I can do it also with the 4 here. And then I can put the 1 here or a 6 there. Okay, that exhausts the 2's in the second position. Now finally, 4th goes last. I'll put the 2 here and see what I can do. Therefore, I can put the 4 there, and then the 1 goes here. And then I can put a 4 there, and the 6 goes there. Okay, that, I think, completes it. 4217, 4267, 4247, 1247, 6247, 4127, 4627. Okay, so that completes it. So how many did I get in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 22 is the answer to this question. And just as long as you have a systematic way of putting the numbers, and then you just follow the rules, make sure you don't put them in positions that they're not allowed. You have to do it manually. And because there's only 22, it won't take that long. In the diagram, CD is equal to CE is equal to 30. F is the midpoint of C. 2 quarter circles are drawn, one with center at C, one passing through DE, and the other with center F passing through E. X is the area of the region that is inside rectangle GDCF and outside the larger quarter circle. Y is the area inside the larger quarter circle, outside the smaller quarter circle, and outside rectangle GDCF. Let D be the positive difference between X and Y. What is the integer closest to D? Well, as you can see from this diagram, I'm pretty sure that Y is greater than X. And if that's the case, then Y minus X would be greater than 0. And that's what they're looking for. But if it isn't, we can always just take the absolute value. That's not a problem. So what we're really looking for is this Y minus X. That's what they're calling D. And then we're going to round up to the closest integer, which shouldn't be a problem. All right, so let's label this first. This I will call B, and this region I will call A. And then let's label this. That's 30. This is 15. This is 15. Entirely based on what they've given me in the question. I haven't done anything yet. And then the distance on this side is also 15, because that's the radius, right? So you understand, just in that quarter circle. And I think that's pretty much it. That's all I have so far. Okay, so now let's talk about this. The big quarter circle, that looks to me like it's A plus B plus Y, the big quarter circle. And therefore that would be pi r squared divided by 4, because it's a quarter circle. And r for the big one is 30, correct? So that would be 900 divided by 4, which is 225. Yeah. So let's call that equation 1. A plus B plus Y is 225 pi. Okay, so then what's next here? The rectangle. The rectangle, which I believe is A plus X, that's just going to be 30 times 15, right? The dimensions of that rectangle, that's 450. We'll call that equation 2. And then the smaller circle, well, that's easy. That's just B. Smaller quarter circle is what I should say. And that's pi r squared again divided by 4. And this time r is 15. So that's going to be 15 squared, which is 225 divided by 4, which I believe is 56.25. And that would be 56.25 times pi. And, well, that's not really an equation, but it's just a value. Okay, so I think that's pretty pretty much all we will need to figure out this y minus x. All right, so what's the next step here? I think since b is equal to this, I might as well sub it into there. So sub 3 into 1. And when I do, I'll get a plus 56.25 pi plus y is equal to 225 pi. And therefore, when you do this, it'll be a plus y is equal to 168.75 pi. Okay, and we'll call that equation 4. And then now, I can clearly see that this and this can be used to figure out that. How? I'm sure you guys can figure it out also. 4 minus 2. Equation 4 minus equation 2 would do it. If you did that, you'd get y minus x, because the a's would disappear, and be 168.75 pi minus 450. And when you do that math, you will get y minus x is 79.875, and of course rounded up to the nearest integer is 80. And that is the answer to this question. Each of a, b, and c is equal to the number from the list 3 to the power of 1 until 3 to the power of 8. There are n triples abc with a less than or equal to b less than or equal to c, for which each of ab over c, ac over b, and bc over a is equal to an integer. What is the value of n? Let's understand this question first. A is some power of 3, so we'll call it some power. We'll let it be 3 to the power of r. B is also from that list, so it's also a power of 3. We'll call it s. And c, again, same thing, so we'll call it 3 to the power of t. And we are told that a is less than or equal to b, which is less than or equal to c. So they could be all equal, but they could also be, less than. So if that's the case, then the exponents also will behave in the same way, the r, the s, and the t. And we also know that the r, the s, and the t are between 1 and 8 inclusive, because it's 3 to the power of 1 all the way up until 3 to the power of 8. All right, so that is sort of just initial kind of setup, not much information there. That's just coming from the question. Now let's talk about those three values that they want us to concentrate on, these three guys here. So I have AB over C, AC over B, and BC over A. We want these all to be integers. Okay, so what is AB over C? Based on our classification, it'll be 3 to the power of R times 3 to the power of S over 3 to the power of T. And using exponent laws, that will be 3 to the power of R plus S minus T. Got it? And in a very similar way, this is going to be 3 to the power of R times 3 to the power of T over 3 to the power of S, which is 3 to the power of R plus T minus S. And of course, this is 3S, 3T over 3R, and that is 3 to the power of S plus T minus R. Okay, great. So now we want these all to be integers. So we want this guy to be an integer, that one to be an integer, and that one to be an integer. So how do we make them integers? Well, they will always be integers, right? Since R, S, and T are integers themselves, according to that. But not always, because sometimes it might be a negative number. And if it's a negative number, then it becomes 3 to the power of some negative number, which makes it a fraction. And if it's a fraction, then it's not an integer. So we got to make sure that these exponents, these guys, are greater than 0. If it's 0, it's okay, because 3 to the power of 0 is 1. That's an integer. But if it's less than 0, it's a problem. Okay, so here we go. So let's analyze these one at a time. First, let's analyze R plus S minus T. And always going to be looking at that inequality. Got it? Okay. Well, we have to ensure that this exponent this number is greater than or equal to 0. So that means r plus s has to be greater than or equal to t. So this is an extremely important criteria that we must obey for this guy. Okay, sounds simple enough. Now let's turn our attention to that one. That number, r plus t minus s, has to be greater than or equal to 0. Well, r is a number between 1 and 8, so that is going to be greater than 0. And t minus s, since t is greater than s, t minus s will also be greater than 0. So this is going to be greater than 0, and then t minus s, that's also greater than 0. So we're pretty much assured that this whole thing is greater than 0, always. So nothing really to do there. We don't need to, since it's always greater than 0, we can just be assured that this guy is always going to be an integer. So that's very nice. Okay, let's turn our attention to the last guy. The last guy is s plus t minus r, and we want that to be greater than 0. Well, let's analyze it first before I set it equal to 0. I was setting it equal to greater than 0 over on this side, kind of like jumping the gun a little bit, but that's okay. Let's talk about this. Well, s is always going to be greater than 0, so that's not a problem. And the t minus r, since t is greater than r, greater than or equal to, we're assured that that's also going to be greater than or equal to 0. So therefore that plus that will always be greater than or equal to 0. So these two are pretty much guaranteed to be greater than or equal to 0, and therefore making these expressions an integer. So I guess the only expression we really need to concentrate on is that one, which is AB over C, and in particular this very important criteria that we must fill. So r plus s has to be greater than or equal to t, and that is pretty much going to be the majority of the work of this question. So I've got to look at this, unfortunately, in a manual way, meaning r equals 1, r equals 2, r equals 3, all the way up until r equals 8, because r goes from 1 to 8 according to that one. So this is actually very time consuming. The mathematics is actually relatively straightforward, just going to be adding numbers, subtracting numbers, but the time consuming element of it is what makes it challenging. So here we go. Let's start off with r equals 1, and I'm going to make a little table over here on the side, r and the number of triples that I get for each value of r. And then at the end, of course, I will add them. So 1, 2, 3, r goes up to 8, right? So 5, 6, 7, and 8. And then, of course, the total. This is actually going to be the answer to our question right here. All right, let's do it. Okay, so in r equals 1, that all-important inequality becomes 1 plus s is greater than or equal to t. Got it? And always keep in mind that s is less than or equal to t according to our inequality right up here. So that I'm just going to keep that in the frame since that's very important. I think those two pieces of information are sufficient for us to proceed. So if 1 plus s is greater than t, then we got to do this manually again. So when s equals 1, what is t? When s equals 1, t therefore will be less than or equal to 2, and therefore t will be equal to 2 or 1, right? Because this has to be satisfied. Okay, when s is 2, this equation then becomes 3 is greater than or equal to t, and therefore t is equal to 3 or 2. And you kind of just keep going like this until s equals 7. This becomes 8 is greater than or equal to t, and therefore t is equal to 7 or 8. And then the last one, when s equals 8, this becomes 9 is greater than or equal to t, and then t can only be 8. It can't be 9 because t is only between 1 and 8. So you see what I mean? It's just sort of manually doing this for values of r and s. So how many did I get? For s equals 1 to 7, for each of them I would get 2 values. So for those 7 I get 2, and then I get 1 value when s is 8. So that looks like 15. So 15 goes here. So that is an example. I'll keep doing them. I won't do them all. I'll do like the first, well, whatever. I'll do like the first 4. And then you guys can do r equals 5 does 8. And then you can add them all up. But by the time I do the first 4, you will become experts. So here we go. R equals 2. That equation up top, the all-important equation, now becomes 2 plus s is greater than or equal to t. And then we now have to do it manually for all the values. So here we go. And then remember, r is less than or equal to s, less than or equal to t. I just want to remind you that. So we can't use s equals 1 because r is greater than or equal to r. S is greater than or equal to r, so we can't use s equals 1. We have to start with s equals 2. If s equals 2, that equation then becomes 2 plus 2, which is 4, is greater than or equal to t, and therefore t would be 4, 3, or 2. When s equals 3, the equation becomes 5 is greater than or equal to t, and therefore t is equal to 5, 4, or 3. And you kind of just keep going like this, and then when s equals 6, this will be 8, and t would therefore be 8, 7, or 6. When s is 7, this would be 9. T therefore would be 8 or 7. And finally, when s is 8, this would be 10, and therefore t would be just 8. So how many do we get here? For these guys, from 2 to 6, which is 5 of them, it would be, there's 3 for each, 3 values for t. And then for this guy, we only get 2. And then for this, we only get 1. So that's going to be 15 plus 3, 18. So the 18 goes there. Okay, so let's keep going. I'll do 2 more. I'll do 2 more, and then I'll let you guys do it. So I'll do all the r equals 3, and I'll do r equals 4. And then I'll let you guys do 5, 6, 7, and 8 for r. So let me just put in my all-important equations. The most important one, of course, is the r plus s has to be greater than or equal to t. And also remind everyone of the fact that r is less than s is less than t. Less than or equal to s, less than or equal to t. Those equations of inequalities, I should say. Okay, so here we go. So this becomes, therefore, 3 plus s is greater than t. And then we now have to do this manually. We can't do s equals 1 or s equals 2 because s has to be greater than or equal to r. So we have to start with s equal to 3. If that's the case, it becomes 6 is greater than or equal to t. And t, therefore, becomes 6, 5, 4, 3. When s equals 4, this is 7 is greater than or equal to t. T is therefore equal to 7, 6, 5, and 4. S equals 5. 8 is greater than or equal to t. T is therefore 8, 7, 6, and 5. S equals 6. 9 is greater than or equal to t. T is therefore equal to 8, 7, and 6. When s is 7, 10 greater than or equal to t. T is equal to 8 or 7. And then finally, when s is 8, 11 is greater than or equal to t. T is then equal to 8. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 goes there. And then one more I'll do for you. This will there become 4 plus s is greater than or equal to t. When we got to start with s equals 4, remember? So s equals 4. 8 is greater than or equal to t. T would be 8, 7, 6, 5, and 4. When this is 5, 9 is greater than or equal to t. And therefore t would be 8, 7, 6, and 5. S is equal to 6. This would become 10 is greater than or equal to t. T would therefore be 8, 7, 6. S is 7, 11 greater than or equal to t. T is therefore 8 and 7. And then finally, when S is 8, this will be 12 is greater than or equal to t. T is therefore equal to just 8. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and then those next ones I'll let you do. I'll give you the numbers though. There'll be 10 of those, 6 of those, 3 of those, and 1 of those. And when you add up all those guys, it will be 86. And 86 is the answer to number 25.